Welcome to Physics with Batman. Almost gave away my secret identity there. Welcome to Physics with Batman, and I'm here today subbing in for Miyoshi, and we're going to talk a little bit about a displacement and velocity activity. We're here in the Miyoshi's garage. I don't want to give up my secret identity, but to discuss this little displacement and velocity activity. So, main thing we're going to do is we're going to try to, most schools are laid out where they have, or many schools are laid out where they have little squares, 1 foot squares in the case of our school, and those squares can help us to figure out what our schedule looks like. So we're going to go out, for instance, if I went out from Miyoshi's door and went out 7 feet, 7 squares, and then went out 50 squares, I would probably be outside the door, outside the school, but I could figure out how big that displacement vector was. So if I just came up and out 50 feet, that vector would be here, and I could see it looks something like this. Now, the D, if you will, is that guy there, and if I use the Pythagorean theorem, and remember, vectors, we can add vectors. It doesn't matter if I add the north-south vector first or the east-west vector. So if this is 7 feet north and this is 50 feet west, I could still do the dx and dy. And this guy here is my 50 feet. So using the Pythagorean theorem, d squared is dx squared plus dy squared. I have 50 squared plus 7 squared. 50 squared, 7 squared. And that's 2549. This would be feet. Then we take this guy, actually it's feet squared. 2549 feet squared, take the square root of that, and we get 50.48 feet. Then, remembering our trigonometry, that the tangent of theta is dy over dx, and the theta is here. It's also here. So 7 over 50 is my tangent. So theta is the arctangent of dy over dx, which is the arctangent of 7 over 50, which is arctangent of 0.14, gives us 7.969 degrees, in this case, north of west. So my vector for my displacement is 50.48 feet at 7.97 degrees north of west. Now, most classes aren't just going to meet outside. Most of the time we're going to come out and then we're going to come up and maybe we'll come over here again to this room. So if this was something like 10 feet maybe, and this is 10 feet, and this is 20 feet, then I could actually make a new vector. I can add my north vectors to my west vector and get something more like, well, let's just put it here. This. So now I have my 10 feet, 20 feet, and 10 feet. This would be something more like a displacement vector of 20 and 20. So this guy here would be the square root of 2 times 20. So it's going to be about 30 something feet. And the direction in this case, we would know, since this is 20 and 20, we would know that this angle was 45 degrees. So we would use something, knowing a few things about trigonometry and Pythagorean theorem and some other things, we can figure out all these guys. And here's one more example. Maybe I'm going to come over here and go out 10 feet and come over 30 feet and back down 10 feet. So if this is 10 feet and this is 30 feet, if I add my two, one going north and one coming back south, those will add back to 0, and so my total displacement here would be 30 feet in this direction, east. Okay, now how do we find the velocity? We would find the velocity by taking our change in magnitude, or our change in direction, or our direction vector, divide that by our time. So if it took us 3 minutes to get next door, then I would have 30 degrees east, and my my velocity vector would also be in the east direction, but I would take my distance divided by my time, and I would get, in this case, maybe it's 30 seconds, 30 feet divided by 30 seconds in the east direction. That would be, what is that? 1 foot per second in the east direction. So, as we are doing this, you'll make your own schedule, hopefully, and you'll try to figure out what your total displacement was between class to class. And if you figure out your velocity in velocity vectors too, that's the other thing you're going to do. And we'll figure out what our total displacement is from getting into your school to leaving your school. And if you think about that a little bit, hopefully you'll come up with the nice round answer there. So, subbing in for Mr. Miyoshi, thanks for tuning in for Physics with Batman.